Hey folks, my name is Dan Meyer. So pumped to be here with you all. I have been a teacher, a researcher, and currently work as the director of research where I explore the future of mathematics, teaching, learning, and technology. I am so pumped to be here to chat about a very timely and urgent topic. I feel like the youth group leader who is seeing a bad case of mono rip through the entire youth group, and I'm turning my chair around and saying, "Listen, y'all, we got to talk." And if that metaphor for an urgent conversation doesn't land, then maybe y'all need religion. But here's another try at it with this right here. This boat in this wave. This boat on the choppy seas is you folks, and the wave is the buckets and buckets of technology that is flooded into your schools over the last 10 years on the tides of lots of federal, state, and local funding, venture capital, philanthropy. All this. There are lots of devices in your classroom, and this is me. This right here, I mean, you might think that George Clooney is you, but no, definitely me. And I am feeling very concerned about what all these tools are doing to you and students and to mathematics. And at the same time, that's been on my mind for a long time. But as I'm preparing this talk, these new large language models, these new forms of artificial intelligence have emerged and have people wondering a question that we should wonder about together, which is, what is a teacher anyway? These new tools invite us to think about what it is that we do. And also, how are your tools producing you? I mean, this is the lie. This is the lie that we often think about. We think like, okay, here's my tool and I use it for my own purposes. But our tools are actually, in a very literal sense, operating on us. In a physical sense, you see people, students, with their smartphones and devices. And it so happens that as the degree of their head looks down more and more at their device, it is the equivalent of hanging a larger and larger weight around your neck, producing what scientists call text neck. Our tools operate on us. They operate on our bodies. They operate on our emotions as well, with lots of researchers finding correlations between social media usage and depression. Though it should be said, they've also found that this relationship reverses itself for certain students. For LGBTQ students, for instance, the more time they spend on social media, the healthier they are mentally, with the researchers hypothesizing that those students don't often experience belonging and positive reflections of their identity in their own local space, and so they find that on the internet. I've experienced this personally, not just that technology tools are producing, us physically, emotionally, but me personally. I use YouTube, as many of you do. And one time I was offered a clip from the YouTube algorithm, a short 3-minute clip from the action movie franchise, The Terminator, a movie franchise that I don't care all that much about. I watched it, and then YouTube offered me more, said, "Do you want to watch some more?" I said, "Okay." And now at this point, it's literally all I can get off of YouTube. It's all YouTube offers me. I press refresh on that thing, another Terminator clip. Why? Don't mind if I do. This is all I am allowed to watch on YouTube now. And in truth, it is all that I want to watch on YouTube anymore, or in my personal life. That's all I want to do is watch clips of John Connor or Sarah Connor lure some cyborg into a big vat of molten goo or whatever. I'm just into that, my kids want to watch Bluey or something. And it's like, no, TV's taken, wife wants to watch a romantic comedy. I'm like, Terminator is a romantic comedy. I love it. And that's funny, and so this has had a shaping effect on my preferences in media. This is the lie. What's actually happening is that simultaneously our tools are using us. That we see that phones produce text neck, social media can produce depression, YouTube produces my Terminator obsession, technology produces students, and technology also is producing you. And to drag research into this briefly, activity theory describes how subjects are not only expressing themselves, they are produced by these activities. I want to know, how are your tools producing you? How are your tools specifically producing your ideas about math, about students, and about teaching? You are being shaped by that giant wave of technology that has flooded classrooms over the last 10, 20 years. To orient us here, I would love for you to think and type into the chat What do you love about math? What is it that we should preserve and protect from these Terminator technology tools in classes? What do you love about mathematics? Would you think about that right now and type into the chat a thought? Just a brief little reflection, a remembrance of what you love about mathematics. And I'm gonna check this out in the chat myself. I'm super curious what you were saying. Also, I'll tell you this, is that for me, what I wanna protect about math is the fact that math is a many splendored thing. It doesn't have just one or two splendors, it has many of them. That math is, in fact, creative, that students are ideally in high functioning, engaging math classes, students are creating lots of representations of math inside their brain. And this is not the case for so much of K-12 math education technology. I'm going to show you an example of some tech that will shape you and your students' ideas about math class. It's a very popular large tool. It happens to be free, which I love. It's called Khan Academy. It is not uncommon. I'm using this because it's free and available, but this tool is just like most tools that are in use in math classes today. And we're going to go through K-12 mathematics today. We're going to speed run through it in about 45 seconds, 2 questions per grade. What I'd love for you to do is just let it wash over you, this feeling of what is being created. Here it is. Here we're starting out in K. Which shape is a square? Let's roll through. Multiple select, okay, which adds up to 82. Get some money going, heading into 3rd grade here with time, maybe some division. Okay, still rolling. Angles, right? Keep this going, okay? Coordinate plane, rock on. Okay, and we're moving into middle school, probabilities, perfect, okay. Solutions of systems, Pythagorean theorem, combining like terms, evaluating expressions, functions, geometry, composite functions, and that's it. Congratulations, folks, you have graduated high school through Khan Academy. And what I hope you felt wash over you is the monotony, the kind of uniform kinds of creations that you create in math ed tech in these dominant forms. I went through Khan Academy one day, one lonely day, and completed all of grade 8 mathematics. And as I did that, rated as mastering grade 8, I wrote down what it was I created every question I answered. And I created this graph of what I was doing. And what I notice here is that over 2/3 of what I created in this dominant model of math ed tech was numbers and multiple choice. That over an entire year, just 2/3 of numbers, multiple choice, numbers, has a shaping effect on you and your students and your ideas about mathematics. It's this idea that, well, math is a monochromatic thing. You need 2 colors in the paintbrush, numbers and multiple choice. And I invite you to wonder how many colors are on your students' mathematical palette. It's so dreary in my view that I actually interspersed in that clip of K-12 math online some video of me doing my taxes on TurboTax. And don't say you noticed it. I know you didn't because no one said anything. But they were in there, and it's striking how similar doing my taxes feels to doing math on the internet these days. Here's several examples. That's like taxes on top, math online on the bottom. And whatever we disagree on, you and me, can we at least agree that doing math shouldn't feel like doing your taxes? And in addition to being just a good expression of mathematics learning, to have more colors on your palette, it also protects you from tools like photomath, which are robotic AI tools designed to solve automatically robotic monochromatic mathematics. Photomath, if you haven't heard about it, it's a scourge, according to Hot Wee Wee Jefferson right there. Beware this app. Photomath, students love it. Marry me. Never judge me for checking 7 + 8. Eventually, relationships need to be reinvigorated. You grow dissatisfied, perhaps. Do some word problems. What happened to my 3% I missed on that test right there? And Khan Academy is very easily, and other math ed tech tools like that are very easily defeated by photomath. For instance, you just go to Khan Academy here, you point the camera, at it. There it is. Grab that monochromatic math problem. It recognizes it, it solves it, it shows you the steps. You type that in, G equals 4, hit it, you go, and you got it. And so what I'm interested in here is in broadening through technology, not in spite of technology, the number of colors on our students' mathematical palettes. At Desmos, where I work, we have worked very hard to invite students to create using math things like turtles and polygons and kaleidoscope art and marble slide runs and transformation golf holes, sketches, more turtles, laser mirror challenges, pumpkins that you carve using coordinates and share in a gallery with your friends, your classmates. This is an example of using technology to invite students to express themselves using the full colors on the mathematical palette. And moreover, Photomath has no idea what to do with it. Photomath is like, okay, sorry, no dice. Okay, this one, oh yeah, it's a linear equation. I can do things with that. Not the right things here, but a thing. Let's try this one. Okay, I got like a word like rotate. Rotate, that means like 180 degrees, a pi. Okay, nope, can't do anything with this. So we're trying to create, humans creating mathematics that robots can't solve. It's good for you and good for your students. So the Terminator tools that are out there invite you to believe they are shaping your expectations to think that math, it has 1 or 2 splendors max. That's all. If you are a teacher who believes, as I do, that math is a many splendored thing, then you need technology that will shape your mind and your students' minds accordingly in such a direction. In the chat, I'd love to know, like, what do you love about students? I'm broadcasting right now on summer. And so, it's like students we're all feeling great, like kind of miss them a little bit. But like, what do you love about students, your relationship with them, and what's worth protecting from the Terminator tools that want to shape our ideas about students in a different direction? Toss into the chat, would you? I'd love to hear. Let's get some going. And I'll just say this, that I love how students are very smart, even when their answers are very wrong. And I think I've experienced this. You don't have to have like biological or, permanent kids in your household to become a good teacher. Far from it. I did have like the experience of noticing that when my little kids were wrong about things, like when they saw an artichoke for the first time and called it a pine cone, how I felt inside of me a great love and appreciation for how smart their wrong answers were. Like, oh, I see where you're coming from here. They both have these leafy, pointy things. That's brilliant, even though you're wrong. And the same is true for students in our classes, however. And I want to protect my students' understanding of themselves as very smart, even when their answers are still very early or in process. And I noticed that the Terminator tools, the education technology in math classes, like how it handles wrongness is the same no matter what. It's like happy and plucky and trying to be upbeat about it. Give it one more shot. Not yet. It's not saying you're dumb and should feel bad. Far from it. But it is only saying you're wrong. It doesn't matter if on a problem like this, maybe I mistook this for multiplication and wrote 30 instead of 13. Like if I wrote 30, that indicates a certain kind of smartness. But if I write 30 or, Terminator here, the same thing happens every time. It says, not quite yet. You're wrong, but not quite yet. It doesn't differentiate between the smartness of those two answers. This gets really frustrating for students, I think. There's a whole forums dedicated to the frustration of typing in an answer that is right and being told you're wrong, for instance. Like a student is wondering, am I smart in math? I kind of feel dumb sometimes. And they type in, 9 halves and 7 halves here for this matrix. And, no, sorry, the correct answer was this. Your answer was that. These are not the same. You are wrong. Or it gets even worse, where it's like, come on, come on. Like, what do you want from me here? And so I want to tune into the kinds of feedback that math ed tech, the Terminator tools that are shaping our ideas about math and teaching and students, what kind of feedback they offer students. And I'm thinking about the stuff that students oftentimes like much more than math class, stuff like sports. And like, why do kids like sports more than math? Oftentimes it's because of how the environment of the sport treats students and their wrongness and their work in process. Like, first of all, in basketball, check out the palette here. Like, the goal is to get the ball in the hoop. You can do that with red, blue, green, yellow colors. You can take a jump shot, layup, Euro step, fade away, one-legged, Dirk Nowitzki, whatever, here, all these different options, right? And I want you to think about what students like about the feedback in basketball. What doesn't happen is you don't get this. This is what math ed tech offers students the Terminator tools most often, is it'll tell you you're correct and tell you when you're wrong, and that's it. But it's not useful or interesting, and it doesn't credit the students enough for the smarts that is in their wrong answers or wrong shots right there. Instead, what I want to know is information about what I did that was wrong. And in basketball and lots of sports and in learning in life, you get that. Like, does the ball go off to the side? It doesn't matter that it says, like, not quite, like, try again. It doesn't do anything for me. I'd rather just know straight up, you missed it. But to learn, like, what happens to each of those balls that miss? Does it go off to the side? Does it go in? Does it go long? More spin, less spin? It's this idea of enriched feedback. You're wrong, and here's information about it that lets you change and grow and develop. I'm thinking about an activity we have called Function Carnival, for instance. And it starts off very simply. We just watch this video right here. Going up, going down, this Canon person. And I love to ask students, like, what do you notice here? Noticing is a color on the mathematics. It's one of the splendors of math, is just noticing a thing and putting it into words, noticing a pattern or a relationship. And then to ask the students, like, can you graph what happened to the height off the ground of that person over time? And to first, like, not do that algebraically, f of x equals negative 16x squared or whatever, but just draw with your finger in the air what that graph looks like. To gesture being one of math's available splendors that students should experience more often. And then to invite them to actually graph in this activity called Function Carnival, which you can use for free at teacher.desmos.com. And so here we have this right here, and they're going to graph it. And a student is very likely to graph something like this right here. Okay. And the Canon person goes up and comes down. It's a very natural thing to think about and to visualize here. And so my question for you is this: is what the student did right or wrong? Or ding, what is it here? Because math ed tech, the dominant model, these Terminator tools only allow for one of two answers. It is either the correct or the incorrect. But you and I both know that student thinking, it's always a combination of both. It's most often wrong and right. And what students need is not a happy message about how they were entirely wrong, the red X, but rather more information about what they did. So what we do here is to offer students a reflection. We interpret their graph back into the context and say, hey, here's what you did. Here's what you're supposed to do. How do you want to change your answer next? The equivalent of picking up the ball off the ground, saying, I see what I did there. The ball was short, pushed out farther next time, and shooting again. I got to say, like, I love how as a math community, we have moved past this idea. Like we developed this idea of telling students, hey, your answer is wrong now, but that just means it isn't right yet. And that's a very happy message to give students. But I want to upgrade that a little bit. Let us upgrade that a bit to instead say, hey, your answer is smart now. Your answer isn't right yet communicates to students that your value, the value of your thinking, is off somewhere in the distant future when the answer you give matches the one in my head or the one in the textbook. But that is a more depressing message, one that does not communicate a student's value as much as your answer is smart now. The Terminator tools are out there trying to convince you and your students that students are smart only when their answers are correct and in a form I understand. And if you want to convince students and yourself that students are very smart, even when their answers are very wrong, you have got to find tools that tell you and tell students about the wrong answers, that don't even evaluate it as right or wrong, but just give more information about it. Student offers a thought and the device responds in a interesting way and allows for more iteration and more mathematical thought development. I want to move into my last question, which is what are these tools doing to our sense of not just math, not just students, but also about teaching, and to do so by reflecting on what you love about teaching. What these tools are shaping all of our ideas about what it means to be a teacher. They are shaping the world's idea about what it means to be a teacher. So let's reflect for a moment on what you love about teaching. Feel free to toss into the chat an idea about what kind of action in teaching do you love about it? What's special about it to you? Keep tossing those in as you think about it. I will offer my own, that I love that teaching is a very sophisticated set of skills that I would summarize as saying the work is to invite, celebrate, and develop student thinking. And I love seeing that kind of work in this video clip I'll offer you of Jen Esmendi in San Diego, California, responding to a student whose answer is wrong in front of the class, which is one of the most intimidating actions or scenarios I know of in teaching. A student is wrong in front of the entire class. How do you protect that kid, challenge that kid, develop the whole class's ideas about wrongness and rightness and the value of that student and thinking? Here it is. Check this out.
All right, who can share with us, how did you get your solution for the system here? What did you do to get the solution? Let's go here from Max.
I wrote 5 equals x minus 7.
Okay, y equals 5. So did you put 5 in here? Repeat again what you said.
5 equals x minus 7.
5 equals x minus 7. Is that, okay?
The slide there says, the caption says indistinct chatter, but what it should have said probably is the students all light that kid up for being wrong. And this is pretty challenging. I'd love to know what you would do here. I'll offer you what Jen does next. It's pretty special. You know, Jen in this moment, she's like listening and she thinks she's heard a thing and realizes she heard a different thing. And so she backs up and says, hey, what'd you say there for real? And then check out what she does next.
What are you realizing?
Never mind.
You sure?
I forgot.
Okay. But Max, what are you realizing?
X equals 5.
X equals 5. So now you realize that. What do you think you should do now instead? What should you do? You got this.
Solve for y.
Solve for y. So what do I do with this piece right here?
Put x as 5.
Okay. And what did you get for your y?
-2.
So y is equal to -2. So is -2 our solution to the system?
I just love that moment. This right here is the work of inviting, celebrating, and develop student thinking. She invited Max, and Max came in with some ideas that were wrong. And there was a moment where Max said, hey, I can get us both out of this. When Max says, never mind. And a different teacher might have said, okay, that's fine. Like your answer's not right yet. We'll go to someone else right now. But when Jen sticks with him and asks this question, what are you realizing? A question that is impossible for any kid to get wrong because it sincerely inquires after what they are thinking now. I don't know, folks. I feel just very grateful to have been in this job long enough and to have had conversations often enough with people like you to be able to recognize Jen's move there for what it is, which is an act of love. That's the only word I have for it. That kind of gesture that Jen offered to Max to bring him back into the fold. That is love. And that's available to all of us. And whatever happens with our tools, whatever else happens, I want our tools to amplify that feeling of that sense of value in a student and their ideas and the ability to do something productive with that and help people like Max see like what you offered us here was much more than just an interesting way to get through a wrong answer towards a right answer. Max, you showed the class what it looks like to persevere through a wrong answer. That's special stuff. And so like I'm going to actually blast through a couple here. What I need from tools and the tools that we try to create within Amplify at Desmos Classroom are tools that put teachers in close proximity to the ideas students are generating in progress. Whereas so many tools offer teachers red X's and green checks and bar charts of correctness over time and by standard, all of which is just it digests the interesting student thinking. That has already happened, the student thinking. And now we will share with you what has gone through the data blender and show you which students have what kinds of value. What I want to know is what students are doing as their thinking is in process. To see all these different ideas from students, to see a couple that are like, oh, that's interesting. Those are both very similar. And to be able to present these to students and say, how are these sketches the same or different, and create more value out of student thinking, to invite that thinking, to celebrate it. This is interesting, and develop it. How are they the same? How are they different? What advice would you have for one student over the other? Or like a moment when I first taught this in a class in San Jose, California, and I was looking at the dashboard like this and scrolling on down, and I just noticed a thing, and there it is. And I just want you to imagine who this student is and what's going on for that kid. You know, it's not hard for me to guess that student has a somewhat challenged relationship with either math, a teacher, classmates, or all the above. That I don't feel super successful here in this class. I'm going to do a thing to either amuse me or press the teacher or both. I'm going to do this. And because the software doesn't say, you're wrong, do it again, not quite, because it just passes me that information, I'm able to work something in that classroom right then and to grab it and say, hey, everybody, pause what you're doing. This is so interesting. You've got to check this out. And I ask the question, what do you think will happen when we press play? And to hear the class talk about, well, there's going to be more than one Canon person, an army of Canon people. How many at most? And for that student who offered this smiley face to realize, like, we've been talking about my thing for the last 10 minutes. What is going on? That's a powerful moment for a kid that testifies to the power of a teacher. My power, your power, to say, I can tell you what's valuable, but only if I see it. And if I want you to know that your in-process thinking, even your random thinking, is valuable, I need to be able to see that in process, not just the data or the percentages or the line graphs at the end of the data digestion process. And what do we do here after all this is said and done? We just play the thing. Bloop, 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 bloop. Bloop, bloop. Okay, bye-bye, bye. That's a moment. That's the technology amplifying my sense that teaching is about inviting, celebrating, and developing student thinking. I've been at this almost 20 years in math education. Some part of that spent teaching students, other parts doing other things, but I've only done this work. In high school, I had a hot dog making job, but this is the only work I've done. I can summarize all of that learning with folks like you over time with one slide, one sentence, which is that students like and learn from teachers who like and learn from them. You got to get technology that puts you in a place to learn from your students, that gives you something to learn about and to like about what they're doing. And the bar graphs, the red and green boxes, the line graphs, all that digested data is not going to do it. You look at this right here, and it's the same kind of math as that function carnival at Canon person, but it's like multiple choice, numerical response. It just doesn't offer much for me to like and learn from. I won't even see this stuff. I'll see at the end of the line, I'll see that they eventually got it right or did not, but it doesn't offer me something that is worth us all learning from. And so when you think about what this right here does to the work of teaching, you see it in classes like this PBS NewsHour report, where you just see students looking depressed, looking like a call center, like detention. And the work of teaching becomes encouraging the students to persevere through a dehumanizing experience. That hand on the shoulder says, I see you kind of drifting, get back on task. It seems affectionate. I'm sure there's a lot of affection there, but it is ultimately about enforcing compliance, which is why you see in these studies out of the Gates Foundation, for instance, here, ask students across the nation, in your class maybe, like, do you feel safe? Do you feel like you belong in this community? 90% of kids say, I agree, or I strongly agree. Then you have all these kids in these laptop schools, lots of technology flooding in, doing these kinds of call center looking personalized learning models, and you see a significant dip in their feelings of safety and belonging. The Terminator tools are telling you the work of teaching is to enforce compliance. If you want to believe this, if you believe this, you need tools that help shape that within you. You need tools that get you closer to student thinking, not farther from it. So let's wrap up here and think about, like, people are talking about teachers getting replaced. What is a teacher anyway? And I want to offer to you that if a teacher is someone who assigns problems from a limited mathematical palette and only offers students right or wrong feedback and only looks at like data displays at the end of it, what you basically have is a robot with a healthcare plan and a pension plan. And robots don't need healthcare, maybe some oil in the joints now and then, or a pension plan. And so we should not be surprised if people say, hey, let's get rid of the healthcare plan and the pension plan, fire the humans and replace them with robots. But if instead you believe that a teacher is someone who invites students to work through the entire mathematical palette, all colors, who thinks that the job of teaching is to offer students interesting feedback on their ideas in process, that is a teacher for all time, for all technologies. And you need technologies that will amplify rather than undermine those tools. Reflect, please, on what your tools are doing to you every day, how they are shaping your ideas about math, teaching, and students, and how they're shaping your students' ideas about math and teaching and themselves. All of you need to use your tech. Please don't let your tech use you. Thanks so much, folks. Happy to have some Q&A here. Talk to you soon.
Hey folks, it's me again. Confession time. That was pre-recorded. I know it's shocking. I told myself you wore something blue. Wear the blue shirt. I think I wore a slightly different one. But in spite of kind of the awkwardness of lack of responsiveness in the talk, I'm here watching the chat and just loving the testimonial you folks offer to what is wonderful and lovely about students and math and teaching. And I feel very protective of everything you've said here in the chat, and want nothing more for my professional life to spend it building tools and curriculum for you folks and support to help you do exactly what you're describing here. Everyone's talking about those moments where students have an aha moment. And I just love that it's, you're talking like about the aha about math, but you folks know also that students are having those aha moments about themselves. It's not just like, aha, I figured this out, like how to do this operation or unlock this concept. They have an aha moment about themselves as math learners. Like, oh, math is a thing that is doable by people like me, which is so special. And I just find that that's so absent when students get this very binary feedback, which is in substance very harsh, even if in style it's cheerful and plucky and you've got this, you'll get it later, you're not right yet. It still is like, you're wrong, you're right, I see no value here yet. So I loved all this. Thanks for participating. Bring yourself. If you have questions for me, please toss them in the chat. I wanted to offer a quick clarification. I work for a company called Amplify. I mentioned Desmos. There's like some merging of the two entities that is still in my language model a little bit. If you want to see what we've been building, you can check it out at Amplify at amplify.com and look for our teacher.desmos.com. We'll get you to the curriculum that we've been building and the support tools. I would love to know in the chat. This is supposed to be for you to ask me questions, but I have questions for all of you, which are like, what helps you with your tools? What do you need from your tools that you're not getting? It'd be so helpful to know that from you. For instance, Chantel mentioned a struggle with a certain tool in class. And given when that comment came in, I think it was about right-wrong feedback. I'd love to know like what tools are working for you in your class. I'd also love to know if you're using AI. There's a lot of folks, there's just like a lot of excitement, which I imagine is more intense when, like me, you're outside of the classroom building tools. And also, like me, you live near the Silicon Valley. I'm here in Oakland, California. I'm just super curious, if you don't have a question, but want to toss an answer, I'm just curious if and how you've been using generative AI tools like ChatGPT or Conmigo or Magic School, these kinds of tools. Like, have they been helpful for your practice? So that's an assignment for you folks to do. I'm going to mute myself and see what comes in through the chat and say so long, if nothing. One reason that technology fails students and teachers is that students, when they're learning math, just like learning language, they come in with kind of an informal language for math and for learning to read or write or speak. You know, they have like a, I don't know, like just like slang or kinds of words that they've repurposed from other places. They grab, like, it's like an informal language that in math class manifests in like sketches and gestures and utterances. And they say and on, they backtrack over themselves, and they overgeneralize an idea that they shouldn't, or they undergeneralize an idea that they should generalize further. And I just notice, I think that computers don't speak that language very well. Like, I've worked with computers for a while in math class, and computers are like, I speak the Queen's English really well. You know, bring me math in the form of these and thous, just like really formal and precise, and I will help you so well. You know, I will do so much for you if you can speak my dialect of mathematics. And just to notice how students are not in that place, and what teachers can do is to hear those words, hear that informal dialect, and say, oh, I know where you're going with this. Like, I hear that and I understand that. And to bridge that gap is something very special in my view. And hard for computers to do, which is why we at Amplify don't ask computers to do that very often. Instead, surfacing to teachers the smiley face graphs, the graphs in process, the informal, like, it goes up and goes down, for teachers to make value out of. Okay, it looks like that presentation was so complete that there are no questions whatsoever. Every question you experienced during the talk was answered later in the same talk, which I love. Pat myself on the back for that one. If you want to get in touch, my contact info is on that title slide, which is not going to return. But I'd love to hear from you. I'm fairly easily Googled Meyer at amplify.com. Let me know how I can support your work. It's been a pleasure having you here, and enjoy the rest of the session. Thanks, folks. Take care.